They give us the following graph. So just really quickly, the following graph, they're asking us to find the delta that satisfies this limit for an epsilon of 1.5. Now, they don't give us in question 184 the same setup as in question 182 and 183 where they actually wrote out the inequality. And so that's the reason why it's so important to memorize the limit definition, because the limit definition says for every epsilon greater than 0, there exists a delta such that if 0 is less than absolute value x minus c is less than delta, then the absolute value of f of x minus L is less than epsilon. So we have to have those string of inequalities memorized in order to figure out what our epsilon is. So remember that our c value is going to be the target, what we are approaching. So we will have x minus 3, and I always kind of think about that little arrow as becoming a subtraction sign. So x minus 3 is less than delta. Now, for our particular question, f of x is f of x minus, now in this case, the target, the limit that we have for that is 2. So we would have absolute value f of x minus 2 is less than our epsilon, which they have given as 1.5. Now, of course, you could do this problem translating the given information in terms of target and the limit and the error as well. But just to kind of keep consistency with what we talked about in class, we'll go ahead and write out the inequalities. Okay, so from the inequalities, what we are seeing, and also from this x arrow 3 notation, the x target is equal to 3. Again, we're trying to find delta, so there's never something to plug in for that. The y target, f of x minus 2, the y target will be what the limit is. So the target is equal to 2, and the error is what our epsilon is, and that's going to be our 1.5. So with that written down, we then go and look at our graph and try to see if we can find our delta. All right, so looking at the graph here, we start off at the end of these inequalities. So we start thinking about our y target. So our y target here is 2, and then the error is 1.5. So we have to go 1.5 up to 3.5, and we have to go 1.5 down to 0.5. Now, we then use that to construct our epsilon band. So here, if I continue this out, that will be my beginning of my epsilon band. And if I continue this out, that's the other part of our epsilon band. Now, we want to know when we stay in this epsilon band. So if we look at where we enter the epsilon band going from left to right, we enter it at this point right here, and that corresponds to an x value. And we leave it at this point right here, which corresponds to an x value. Now, the target for the x value is 3. So if you look at where you start and stop for the epsilon band in terms of x, you'll see that here on the left-hand side, you're 0.5 away from it, and on the right-hand side, 3 to somewhere in between 3 and 4, we'll estimate it to 0.5. And so that means we need to choose our delta to be equal to 0.5.